Now, just like when we were factoring our greatest common factors earlier, when we have a leading coefficient that's negative, when the lead coefficient is negative, you have to factor out the negative. So you must factor out the negative. Must factor the negative out. So my greatest common factor here is going to be a -3, and that's going to leave us with an x squared. Now watch what I'm going to do here. I'm going to show my work. Factor out the -3, and that's going to leave me with x squared plus 3x minus 10. Now I need to try and factor that trinomial into two binomials. So I've got -10. How do I get a -10? Well, that would be a -1 and a +10, a +1 and a -10, a -2 and a 5, a +2 and a -5. Well, we need the outer and the inner to combine to be +3. So that's going to give me this combination right here, x minus 2 and x plus 5. So our fully factored answer is -3, x minus 2, x plus 5. Here's one for you to try, and then I'm going to show you how there's not always a greatest common factor. Sometimes we've got a leading coefficient that we need to work with. So go ahead and press play, and when you're ready to check your answer, come on back. Okay, we factor out the -5, which is going to leave me an x squared minus 2x minus 8. So I get -5 times the quantity, x minus 4, x plus 2. And you can have this as -5, x plus 2, x minus 4. It can be in any order, but if you have a monomial, you usually put that out front, and then the binomials follow. Okay, what happens when we have two binomials that we're multiplying together that aren't an x and an x? We have, in this case, 2x and 5x. Well, our first terms end up being 10x squared, right? Our last term ends up being +12. The outer and the inner, the outer is 8x, the inner is 15x. That gives me a +23x. Now what happens if I have 10x squared plus 23x plus 12 and I want to go backwards? Well, what is that equal to? It's equal to two binomials multiplied by each other. And it's just, there's only one answer. It's not like I can come up with one answer and you can come up with two totally different factors. Our factors would be the same. So let's try this. How do we get back to 10x squared? Well, there's a couple of different ways we can get back to 10x squared. We could have 1x and 10x. We could have 2x and 5x. I do notice that I don't have a greatest common factor. 10, 23, and 12 don't have anything in common. So it's not like I can make these numbers any smaller. How do I get back to 12? Well, getting back to 12, +12 would be 1 and 12. My middle term, my second term of my trinomial is going to be a positive, so I'm not even going to mess with the negatives because I need to multiply to be a positive and I need to add to be a positive. So 1 and 12, 2 and 6, and 3 and 4. Well, let me show you something. If I try 1x and 10x, I know for a fact it's not going to work. Because if I try 1x and 10x, here, I'm going to make this really easy. I'm going to space it out like that. So watch. If I do that, then the 12 has to be with the 10, okay? If the 12 was with the 10, 10 and 12 have a common factor, but the original trinomial 10, 23, and 12 does not have a common factor. So I know that the 12 can't go there. So the 12 would end up going over here, right? 12 times 10 is 120. That exceeds the 23. That's not going to work. Now the 2 and the 6, I'm not even going to try the 2 and the 6, because if I put the 2 and the 6 in this position, 10 and 6 again have a common factor of 2, but the original trinomial did not. So that means the binomials aren't going to have common factors. If I switch the positions and the 2 goes with the 10, I still have a greatest common factor of 2 in the binomial, but I didn't have a greatest common factor in the trinomial, so that's not going to work. So I'm going to try 3 and 4. But I know now I'm not even going to try the 4 with the 10. I'm going to try the 4 over here and the 3 with the 10, because I don't want to create a binomial that has a common factor that the original trinomial didn't have. And that doesn't work, right? So this was the only combination with 1 and 10, and that doesn't work because I have 40x and I have 3x, and that's 43x, not 23x. So I'm going to say, okay, the 1 and the 10 was probably a bad choice, right? 1 and the 10 was a bad choice. So let's try 2x and 5x. Now, since I've got the 4 and the 3 there, I'm not going to put the 2x with the 4, because 2 and 4 have a common factor that the original trinomial doesn't have. So I'm not going to put the 2 there. I'm going to put 2x here and 5x here. Now I'm going to check my outer and my inner. 15x, 8x, that's 23x. There's my answer. 5x plus 4 and 2x plus 3. Now you're going to get better at this with practice. So if you're doing what I'm doing in green and you're checking your outer and your inner, you're going to get very good at placing the numbers where they're supposed to go. So I'll show you. We've got 6a squared plus 23a plus 7. I want to factor that. So how does that factor? I'm going to come down here and I'm going to show my work. Well, there's a couple different ways to get back to 6a squared. I could do 1a and 6a, or 2a and 3a. And then I have to get back to positive 7, and I need a positive on the inside. So therefore, I'm going to have 1 and 7. I'm not even going to go with the -1 and the -7. Now I need the outer and the inner to add. They're both going to be positive, and I need them to add to 23, but not go over. Because if they go over 23, I'm not going to have opposite signs to bring the other one back down. So if I go with 2 and 3, I'm going to be combining 2 and 3 with a 1 and a 7, and I can see that 21. Can you see the 21 there? I can see a 21 and a 2. 7 times 3 is 21, 1 times 2 is 2, 21 and 2 is 23. It's got to be this combination of 2, 2a and 3a, and 1 and 7. It's just about placing them. So we'll put 2a and 3a, and then I need to put the 1 and the 7, and I want the 7 to multiply times 3. So positive 7 and positive 1. Now I'm going to do a quick check. 2a times 1 is 2a. 7 times 3a is 21a. That gives me my 23a. So I factored it properly. 2a plus 7, 3a plus 1. I box it, and we're good. Okay, you go ahead and try. Okay, if you pressed pause, hopefully you pressed pause, because now I'm going to go through the answer. The answer is 2y and y, and then 1 and 2. So 2y plus 1 and y plus 2. Hopefully in your work, you've shown the outer is 4y and the inner is 1y. That gives you your 5y, and you did a great big check, and you're good to go.